A few months ago, I made a video about wave energy engineering that I made while I was surfing in Australia. And since then, I've been getting in touch with experts working in the field to find out more about why wave energy hasn't developed as fast as wind and solar energy has over the past couple of decades. In today's video, I talked with researchers from the University of Western Australia, Adi and Hugh. I showed them my first video as an introduction to the kinds of questions that I'm hoping that they can answer for me. The first question is, why is it so much more complicated to harness wave energy than wind energy? And what are people working in the field doing to address this? I had seen a lot of companies mention that they're using machine learning or artificial intelligence to improve efficiency, but I wasn't really sure how that could work. So I asked Adi and Hugh to explain.
It's quite predictable and it's quite energy dense in the resource.
We are dealing with an extra variable.
The devices now which work well are those which have learned the lessons from the past.
Yeah, I saw your video, YouTube video. I thought it was very good. We are dealing with an extra variable, which we don't have with wind. So wind is just a flow of air, right? Whereas wave is an oscillatory motion. We have wind speed and direction, whereas with wave we have the wave height, the direction, as well as the wave period. So wave energy devices, they work optimally when they are in resonance. So because of this oscillating system, right? So they have a resonance. So and obviously resonance it's got a bandwidth, so it's not like flat over a broad range of frequency, but it has a peak and then it goes away.
Okay, so you're saying that the frequency or the period of the wave matters, that for any specific device, there's a more efficient wave period for it to be operating in.
Yeah, because a passive device which is not controlled, they have its own natural frequency.
When companies are saying that they're using AI or machine learning in these devices, is that so that they're changing the natural frequency so that it matches the period of the wave?
One thing we can do is to control it so that it artificially resonate at all frequency, so to speak.
Okay.
But it adds complexity to the device.
You try and adjust it so that it resonates on a wave-by-wave basis. Mm-hmm. So that's where the control comes in, yeah. So it's very short-term on the order of wave period adjustments to the system to try and optimize the power output mostly, although possibly also to limit the motions to the operational range or other things like that.
And so what sorts of improvements can you see, like how much extra energy can you get if you add a smart control system compared to if it's just passive?
It sort of depends on your reference point, I think.
Yeah.
Depends how bad the original system you compared it to was. The figures they quote in the literature are, if you compare, there are been papers published that show that if you have a controlled device against a passively controlled device, you can increase the power you absorb by a factor of 2 easily. But because there's such a wide variety of wave energy devices, these are not necessarily rules that should be or could be applied to necessarily all devices, I think.
Okay, so once again, we see this same trade-off that I've heard from pretty much everyone I talk to about wave energy: efficiency versus complexity. Possible doubling of energy capture does seem like a pretty tempting proposition, but if the associated increase in complexity causes failures in the field and downtime, then it may not be worth it overall. So we have heard a lot about how many challenges there are associated with wave energy. It really does sound like a lot of effort, and I wondered why anyone is still bothering. When people started seriously developing wave energy back in the 80s and 90s, at that time, wave, wind and solar, all of them were kind of similar. They were really immature, really expensive, unreliable. But by now, wind and solar have become way cheaper and very reliable, while wave energy hasn't advanced as quickly. So are there inherent benefits of wave energy that keep researchers working on it? There are still plenty of companies that are pursuing it, so what makes it so attractive, even now when we have alternative renewables available that are quite mature? Why do we still need wave energy to be developed?
It's quite predictable and it's quite energy dense in the resource, so it's attractive to try and tap it. The resource that's out there is significant, but it's not going to solve all of the renewable energy problems that we have, but it seems like it's worth trying. It's also a really interesting engineering challenge. What is the breakthrough going to be? It's been demonstrated that wave energy, it's possible to absorb power, to turn power in the waves into electricity.
Yeah.
And there are benchmarks for how effective that is, but really there's another level of breakthrough needed to make it economic, and I guess that's the interesting challenge.
In my view, it's a bit unfair to say that, like wind and wave, they have like similar length of history, because windmills have been around like for many hundreds of years. The principle is already known for ages, like aerodynamic lift, it's already known. Whereas wave energy, I think the principle is only like understood since the 70s. I guess maybe one thing, there are not actually many people like doing research in wave energy compared to maybe other renewables. You will see like the same device like that was proposed like many years ago, like being proposed again.
That's the key point, is that there is actually a history of lots of different things being tried, and I think the devices which are successful, or those which are the leaders now, are those which have learnt the most from the previous deployments. Certain things have been shown not to be economic. The bits of your device which are in contact with the water and which are activated by the waves to be the majority of what you're paying for. Originally there were ideas that massive underwater focusing lenses, for example, could be used to concentrate lots of wave energy at a point, and then you can absorb it, but you have to pay to build the lens, right? So that's very expensive, and things like that, I think people are probably going away from in more modern designs as one sort of perhaps basic example, but yeah, it's important to learn the lessons of the past.
And it feels like companies today, the ones that I've spoken to, are much more concerned about simplicity and reliability, and taking care of that first, and maybe eventually you go back to efficiency. But do you think that that's true, that the simplicity is really important for a successful wave energy device?
Make things as simple as they can be, but no simpler, I suppose. So there are the challenges there. And we haven't talked much about survival, so that's a big challenge, right? I mean, effectively your income is how your device performs throughout the year, and your cost is associated with just that one big storm that comes through, in which the power level is 100 times maybe more than it was during the operational conditions. And so that's a big challenge, to operate efficiently, but then also to survive those extreme conditions is still evolving.
If we take as examples like Pelamis or Oyster or Wavestar, they are not bad devices. I mean, they are the leading devices at their time. But yeah, because of this like premature push to put devices in the sea, maybe by the government or the investors, or once, there is a failure which has nothing to do with whether the device is good or bad, but maybe some design issue or something. And then they don't have the money to recover, because they are small companies.
Someone in the industry said to me, it's very important to have patient money behind a wave energy development. You don't want to be in the position where you're forced into a full-scale deployment like Addy's talking about before it makes sense. And then if you are and something doesn't go right, then the same lack of patience can mean that you then draw the conclusion that the whole project wasn't worthwhile and throw everything out. The devices now which work well are those which have learned the lessons from the past, but it's actually quite hard to do that in some ways. You have to do quite a lot of digging around to understand what went wrong. Yeah, it is exciting because there is this background of knowledge now in the industry which can be drawn upon, and companies are doing that. They're evolving their devices. The difficulty is that perhaps you get squeezed out by wind and solar, but the climate, the desire to do something, to have renewable energies work is increasing all the time, right? The amount of renewable energy we need will continue to increase. We've demonstrated we can turn wave power into electricity, so the question is just how do we get there economically? And I think it'll happen.
So how does the future look for wave energy? Will it ever catch up to solar and wind energy technology and become a reliable and economic additional renewable energy option? What needs to happen to see it mature to that level?
I think a wave energy device needs to be like adaptive as a wind turbine. It has to be able to cope with these varying conditions and varying loads. Whereas I think devices that present nowadays, they don't have this capability.
Most of the devices have survived their field trials. I mean, some of them haven't, clearly, but like it's not like they've all been destroyed. It is a challenging environment, but it's sort of been demonstrated that devices can survive. But the question is, are they designed economically to survive, I guess? How do you translate this elegant theory that gives you these very nice results and hints at sort of vast potential? How do you translate that into a device which can be realised physically and survive and be economic?
Thanks for the chat, Addy and Hugh. It was really great to learn more about the complexity of wave energy resource and how companies are addressing it. It was especially interesting to hear them say that the future of wave energy is going to involve more incremental technology change and making sure to learn from earlier technologies to copy their strengths and avoid their mistakes. That's a theme that we've been hearing again and again from the experts that I've been talking to who are working in the field. If you haven't checked out the rest of my series on wave energy, then have a look now. And if there are any questions that you have, then let me know in the comments. I still have a couple of videos planned in the series on wave energy where I can answer these questions. Don't forget to like and subscribe because that lets the YouTube algorithm know to recommend more videos similar to this in your feed, and it's also a free way that you can support me to make more videos. I have lots more videos on wave energy and other green energy technologies on my channel, so check them out and I'll see you in the next one.